Hello, hello, hello. I'm back again. Okay, now we have a new project here, and this is I just want to look at having a different bars. Each bar has its own frequency. Okay, so because it has its own frequency, I also added a ripple effect. Sort of as it moves up, it sort of has the bit of a ripple effect, and you can see it as it's close up. Okay, so the louder the sound and the more the ripple effect as it moves upwards, and each bars will have its own frequency. Okay, sorry, and I will put the code on the YouTube channel. Okay, so let's have a look how this one works. It might have, it's the same principle. It's an OLED screen, okay, with the ESP32 and a sound sensor, okay, which has got a pot to adjust it. And if you look all my other video, I have the same principle. Okay, this is just a different wave. Okay, so we put it a little bit higher now, but it's also nice when there is music, okay, which I cannot use at the moment. But also, yeah, and it's all the bars. You can see that they have their own frequency. Okay, it's not a loud talker, but there is some other noise. But you can bring it down a bit. Hello, hello, hello. Yeah. The louder noise, and obviously it's come up, but I think you can adjust it like this. Maybe not too much. Yeah, that sounds better, but okay. So this is what it looks like, and I think once you have a music on, it looks very nice. Right, here's a code. Alright, so you have the same code as some of the previous one. Obviously in this case we have an OLED screen. We're not using the computer socket, so it just had Adafruit and Adafruit SSD, which is the library for initialize the OLED. Okay, then we have the mats.h, which is a library to calculate geometric mathematicals like cos and sins and so on, square root, cubic root, and okay. So here we have a pin number 4, which is the sound sensor that processes the wave. Then okay, here we have the rise factor 0.1, but you can change the rise factor, the fall factor, so it moves up and it moves down when the sound goes away. So, and with this you have the ripple offset, which you can put 1 to whatever you like, and you can, I'll leave it to you guys, I'm not going to, that you can play around and find the best. The wire begin, you need it if you have a different structure. This one can also work with an Arduino, by the way. I mean, there is no network, there is no use of network or anything like that, so Arduino will work perfectly. Okay, or any Arduino. You can use Nano, Arduino Uno. All these projects that I have done with ESP32 can be done with Arduino. Okay, except the one that require the Wi-Fi, or that requires, yeah, practically the Wi-Fi. And yeah, obviously you can use, if you, if you some of them require internet. So okay, so here it's carry on. This is a mathematical calculation here. Let me enlarge it. No, you can't make it bigger. All right. So, and I will post this one on the. I will post this one on the YouTube channel as usual. Okay. So, and that's it. I don't think we've got much to talk. It's a simple dancing bars, individual bars. Okay. So. And remember also here we have a capacitor. Here's a capacitor. That's a capacitor, okay? I think it's about 100 microfarad, okay? Remember let me just show you. Okay, I'm not going to take it off because it's plugged in, otherwise it can cause a short circuit. Because remember, the capacitor, even if you take it off or you put it back in, it's still got power in. It's like a battery in a way. It's charge and discharge, charge and discharge. Okay, so and the reason why it's used here in this case is to eliminate noise pollution or electrical noise. Okay, so the long leg, if you see here, the long leg goes to positive VCC and the short legs goes to ground. Okay, so you got that. You can also use a ceramic one. I mean, it doesn't have to be capacitor electrolytic. Can be a ceramic one. Okay, so I think we cover everything. As I said, I will post the code, and you can just change it to make it adjust to your like. Okay, guys, have a